Example 1. Find the degree and leading coefficient for the given polynomial, then determine the end behavior of the functions. When we want to determine the end behavior of a function, we have to first look at the leading term to find the degree. The leading term is going to be the one that has the highest exponent of the variable, which in this case is x. So for example A, this is our leading term, and the leading coefficient is -2. So our leading term is -2x to the fourth, and the leading coefficient is -2. What we really care about is if there's a positive or a negative in front, because a positive means that the function is facing in its normal behavior, and a negative means it's reflected across the x-axis. Anytime that the highest degree, the highest exponent is even, the function will behave like an x squared graph. So a normal x squared graph is going to be facing up on the ends like this. And if we have a negative x squared, then it means it's going to be flipped upside down, facing down. So I think that in this context, because we have x to the fourth as our highest exponent, our graph is going to look like this. So for our end behavior, what's happening way at the extremes of the graph, as our x values go towards positive infinity, our y values are going down towards negative infinity. That's this side of the graph. And then as our x values are going towards negative infinity, our y values are also going down towards negative infinity. That's this side of the graph. Let's look at another example. For example B, we have two different parts of the function. It hasn't been multiplied together, but if we were to distribute this x squared, it looks like our leading term would be 2x to the fifth power. The leading coefficient is +2. So when the highest degree is odd, then the function will look like an x cubed graph. So this is what an x cubed graph looks like. And if there's a negative in front of the leading term, then the function will be upside down like this. We've got a positive leading coefficient, so we think that our graph is going to look like this at the end behavior. So for our end behavior here, as x goes towards positive infinity, our y values are going up towards positive infinity. That's this part of the graph here. And as our x values are going towards negative infinity, our y values are going down towards negative infinity. That's this part of the graph here. One more example. This also is set up in factored form, and if we have to think about what would happen if we were to multiply this out. So let's look at this part first. If I were to multiply this part out, I would get as the leading term, this guy would be squared here. And so that would be a 4x squared. And then if I multiplied it by this, I would end up with 4x to the fourth power for my leading term. Just kind of thinking through what would happen if I were to multiply all of that stuff together. And then it looks like our leading coefficient is 4. All right. So since this is to the fourth power and we have a positive leading coefficient, we know that our graph is going to look like this, like an x squared graph. So for our end behavior, as x goes towards positive infinity, y is going up to positive infinity. And as x goes towards negative infinity, our y values are also going up to positive infinity.